Okay, today we're going to talk about polynomial functions, and we need to start off with some vocabulary so we make sure that we're all on the same page and know what we're talking about. So the first term we need to discuss is not a moon, a monomial. A monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. Okay, so an example, obviously a number could be the number 2. That's a monomial. We could have a variable. We could have a, or we could have the product 2a. And if we have more than one, we could have 2a, or we could have 2ab cubed. But all of our exponents will have whole numbers on them. Okay, the next term you need to be familiar with, make sure you know, is the degree of a monomial. And the degree of a monomial is the sum of the exponents of the variables. Okay, so if I go through, let's go through and talk about the degree of each of these. The degree of this one, it has no variables, which means that the exponent on the variable is 0. So that one has a degree of 0. This one has a degree of 1. This one has a degree of 1 because the variable is just an exponent of 1. And in this case, I would add the 1 and the 3 together and have a degree of 4. Okay, the next thing we have, that's a monomial. What if we have a polynomial? Okay, a polynomial is a monomial or the sum of monomials. Okay, so each of these could be classified as a monomial, but if I wanted to say 2 plus a, then I would have the sum of monomials, both of which are polynomials. Okay, the degree of a polynomial is different from the degree of a monomial in that you take the degree of your highest powered term. So if I added 2 plus a plus 2a plus 2ab cubed, then the degree of each term would be 0, 1, 1, and 4, but the degree of the polynomial would be 4 because it's only the degree of the highest powered term. Okay? Next, we need to talk about standard form, and the standard form of a polynomial function arranges the terms by degree in descending order. Descending means that we go from start at the highest and we go to the lowest. Polynomials are classified by their terms or by their number of terms. Actually, it's not classified by their, sorry, that was not supposed to be terms or number of terms. That was supposed to be by their degree or by their number of terms. So I have a little chart here to help simplify things. Okay, as we just saw, degree 0, the name, if it's degree 0, is called a constant. Okay, I'm going to keep going through the degrees. Degree 1 is, hopefully you know, because we've talked about a lot, linear. Okay, degree 2 is quadratic. Degree 3 is called cubic. degree 4 is called quartic, and degree 5 is called quintic. And some books don't distinguish, and then from here they just say a polynomial of degree 4 or higher. But I think it's good for you to know the words. Okay, that is looking at the polynomial, finding out which is the highest term. Okay, highest term is a 2, highest term is a 3, highest term is a 4, highest term is a 5. You can also talk about the polynomial depending on how many terms it has. This has one term. This has two terms. This has one term. This has three terms. Anything separated by plus or minus distinguishes your terms. So this has two terms, and this has four terms. If it has one term, we call it a monomial. Mono meaning one. If it has two terms, it's called a binomial, like a bicycle. Has a two wheels on it. Back to a monomial. Okay, if it has three wheels on it, it's called a tricycle. So we have a trinomial for three terms. Two terms, back to our binomial. And anything more than that, we can just call it a polynomial. And they leave more room because they want you to say polynomial of four terms, and so just tell how many terms it has. So, write each polynomial in standard form. What is the classification of each degree by, what is classification of each by degree and by number of terms? Okay, so first of all, put it in standard form. That means I need to start with the highest one, 5x to the fourth plus 3x cubed minus x. What is the classification of its degree? Okay, well that answers the first question, so we'll box that. Now, the degree is the highest powered term. Okay, so I'm going to write that it's quartic. And the number of terms it has is 1, 2, 3. So then I'm going to write trinomial. So it is a quartic trinomial. Okay, look at the next one. We have, which one's first? Negative 4x to the fifth plus 2x squared. These two are like terms, so I'm going to combine them. 10 and 3 give me 13. Okay, so that is the polynomial in standard form. Highest degree is 5, so it's a quintic, and it has three terms, so again it's a quintic trinomial. Okay, so the next thing we have to realize is we have the degree of the polynomial affects the shape of the graph and the maximum number of turning points. And the end behavior. So let's talk about what each of these things mean. The maximum number of turning points. What's a turning point? A turning point on your graph is basically any point where your graph changes directions. Changes directions. So if you're thinking of, I have a graph looking like this, okay, then this would be a turning point, and this would be a turning point. So we would say that it has two turning points. Okay? The end behavior. What is the end behavior of a graph? That just means tell me what the arrows are doing. And we're just going to talk about how this particular one would say, we would say that it is, the left one is going down and the right one is going up. But you're going to see, we'll do some examples with that. Actually, we have some pictures to go along with it. So, the end behavior Okay, again, you're looking at the arrows for end behavior. Um, so in this particular graph, our end behavior would be what we would say up and up. Okay, the turning points, it gave us one turning point right here, one turning point right here, and one turning point right here. So we had three turning points. Okay, the function, the other thing that we have to talk about is where the function is decreasing and where the function is increasing. Okay, you follow the function from left to right, and if you're going down, the function's decreasing. So I'm decreasing, excuse me, up until that turning point, then I'm increasing, then I'm decreasing, and then I'm increasing again. Okay, notice that this is a fourth degree polynomial. And whenever you're reading the polynomial, you always want to remember to go from left to right. Okay, over here I have a second degree. Okay, what is my end behavior? This time it's down and down. Turning point, I have one turning point. And the function is, what does it do when it's less than one? This is increasing. Okay, remember I got to go from left to right. That's increasing and then it's decreasing. Okay, and look at these two. We have, again, a third degree. Okay, what is my end behavior? Left arrow is pointing down, right arrow is pointing up. How many turning points? I have 0 turning points because the function is always increasing. So it's always getting bigger and bigger. Over here, I have a third degree again. My end behavior is the left arrow is pointing up, the right arrow is pointing down. My turning points are here and here. And my function is decreasing at that point when it's less than negative 0.82. Then it's increasing and then it's decreasing again, which is why they gave us two places where it's decreasing and one place where it's increasing. Okay, so in summary, what we've just looked at 4 graphs, and here's a little chart to help you remember. Okay, the key thing that you want to remember about this is whether or not your degree is even or odd. And that didn't highlight very well. Doesn't want to highlight for me. Can't go back and forth. Okay, so if it's even, okay, and it's positive, then we know that it goes up and up. It's like a parabola, y'all, so the arrows are going up and up. And if I put a negative on A, this is telling me about my leading coefficient, then my parabola is going down and down. Okay, what happens on my odd function? Okay, the odd function, if you think of just your normal cubic function looking like this, then normally if A is positive, the left arrow is going down and the right arrow is going up. So if you were to make A negative and it flips it, so it's looking like this, then we know that the left arrow is going up and the right arrow is going down. So we're learning a lot about polynomials by just looking at the equation. Considering the leading term, y equals negative 4x cubed plus 2x squared plus 7, what is the end behavior of the graph? So it's in standard form. You should notice that it's odd and it's negative. So if it's odd and negative, then that means that my end behavior is going to be up and then down. And that's all you have to say. All right. The next thing we need to talk about, in general, the graph of a polynomial, excuse me, the graph of a polynomial of degree n, where n is greater than 1, has at most n minus 1 turning points. So look back at what we did when we talked about these graphs. Okay, I said whatever the degree is, then the number of turning points at most is 1 less than that. So if I had fourth degree, notice we had maximum of 3 turning points. Second degree, one less than that is 1. But see, it's at most, it doesn't always have to be that way. So this third degree had 0 turning points, but this third degree had 2 turning points. 1, 2, they didn't ask me where, but they have 2 of them. So what you want to keep in mind is every time you look at one, you'll know how many turning points, the maximum number that you can have. So let's see what kind of things you're going to have to describe about a graph. Okay, y equals negative x cubed plus 2x squared minus x minus 2. Okay, you should notice that this is odd and it's negative. So that means the graph is doing something of that sort. And it might have some turning points. But the end behavior is up and down. The left arrow is going up, the right arrow is going down. Okay? Describe the turning points. We're actually going to go put this in our graphing calculator. Okay, so you have your graphing calculator out, and you're going to put this equation into your graphing calculator. I'm using the Inspire. If you do not have a graphing calculator at home, you've got your iPad that you can put in using the free graphing calculator app to work this exercise. But make sure when you come to school that you know how to do this on a graphing calculator because that's what you'll be using on the test. Procedure is very similar to the zeros. So as we do, I am looking for the turning points. So looking at my graph, again, we talked about turning points are where you might have a valley or a peak in your graph. Okay. By looking at the degree, I know that the maximum number of turning points that I'm going to have, or that I can have by looking at the degree of my polynomial is, okay, oopsie, come on, takes a little bit sometimes. The maximum number of turning points that I can have because it's third degree is 2. And when we looked at our graph, we do have 2. So if we go calculate it on the Inspire, I'm going to hit Menu, Analyze. And this time on that first one, it was, let's hit Escape so we can look at that. This happens to be a minimum. That's a valley. So Menu, Analyze, Minimum. And it's going to ask me for the lower bound, or we said left bound on the 83. Lower bound, right bound. And so it gives me the minimum point of negative 3, and that's the point. So we're actually going to go fill in that point right there. So point 3, we had the point being, was that negative? Let's go make sure. It is point 3, it's not negative. So I have 0.33 comma negative 2.15. Okay, that's one of my turning points. Then I got to go back, and now I'm going to go find this one, which looks like a relative max. So I analyze, I'm looking for a maximum, and I have to get the lower bound or left bound, upper bound or right bound, and here my maximum is 1 comma negative 2. So I'm going to put that point on there, 1 negative 2. So going back, if these are my max and my min, and I'm looking for my increasing. So as I drag my finger left to right, I'm going down, but then I go up, and then I go down. So in between those two x values is where my graph is increasing, in between these two x values. So I'm going to write 0.33 comma 1. That's the increasing interval. And the decreasing interval was everything negative infinity to 0.33, negative infinity all the way up until that point, and then 1 to positive infinity. And just to reinforce that on your graph, okay, looking at your graph, this is negative infinity all the way down to 0.33, and then from 1 all the way down to over to negative infinity. And that's what our graph is doing. Okay, well, let's look at the next one. We have y equals x cubed minus 1. Again, it is odd. It is positive, which means that the general shape of it is doing this, or end behavior. So that means my end behavior, my left arrow is pointing down, and my right arrow is pointing up. Okay, again, my maximum turning points if I'm at a third degree is 2. So I know I'm not going to have more than 2 points here. So I went ahead and put it in there, and it's on the second page. Here is y equals x cubed minus 1. Okay, and if you notice here, this particular graph, if you zoomed in or noticed more, it actually is flattening out, but it never changes direction. So this particular graph has 0 turning points. The increasing intervals, it's increasing everywhere from negative infinity to infinity, and it is not decreasing anywhere. Actually, I shouldn't write no solution. Let's write, and they make me write the whole thing over again. We're just going to put a line across it and say that that's not it. Okay? Okay, so the last thing that we need to talk about is looking at a table of values and using the differences to determine the degree. And when we look at these differences, basically what we are doing is we are trying to figure out if all of these differences are the same. A little technical issue there, okay? So that's supposed to be an arrow. Are all, are they all the same? So poof, I fixed it. What I was trying to say was we're going to use those differences. We're going to look and see if they are all the same. So you take the y values on your chart. We've listed them horizontally, but you can keep it vertically and go out to the side if you want to. And we are subtracting the numbers. 23 minus negative 16. Negative 16 minus a negative 15. Okay? Negative 15 minus a negative 10 is negative 5. Negative 10 minus a negative 13 is 3. Negative 12, or excuse me, negative 13 minus a negative 12 is negative 1. Negative 12 minus 29 is negative 41. Okay, so they're not all the same. These are called our first differences. So we're going to go down to the second differences. And we're going to say 39 minus a negative 1 is 40. Negative 1 minus a negative 5 is 4. Negative 5 minus 3, negative 8. 3 minus a negative 1 is 4. And negative 1 minus a negative 40 is, excuse me, negative 1 minus a negative 41 is 40. Okay, so we started with our numbers. We subtracted it once, first differences. Subtracted those numbers. We're at the second differences. They're not the same. So now we're going to go to the third differences and we're going to look at those numbers. 40 minus 4 is 36. 4 minus negative 8, 12. Negative 8 minus 4, negative 12. 4 minus 40, negative 36. And we're going to go one more time to look at our fourth differences. 36 minus 12 is 24. 12 minus a negative 12, 24. Negative 12 minus a negative 36, 24. So the fact that our fourth differences are all the same means that I have a quartic equation, okay? Or the degree of my polynomial is 4. So if my third differences were all the same, hopefully you realize that means we would have a cubic equation. If my second differences were all the same, I would have a quadratic equation. And if my first differences were all the same, I would have a linear equation. Okay? So use that information, work your assignment, and we will go over questions in class the next day.